Good evening, everyone. I'll just start. I'll just wait a minute or so. I hope my screen is visible to everybody and I'm clearly audible. You all can use the chat box to answer any questions that I ask. Like I'll get into the things, but just checking the few technicalities. I would like to get a feedback from the class if I'm audible or not. Yes or no? Okay. Thank you so much. So let me start today's interactive session. So welcome to the Building Materials and Composites Week 1 interactive session. So I am Purvita Shamanto and I am a PMRF scholar and I'll be presenting or basically we'll be interacting today. So as we all know that our course coordinator is Professor Sumana Gupta, who is also from the Department of Architecture and Regional Planning, IIT Kharagpur. And so basically let's see what we have for our class today. Okay, so it's basically a doubt clearing and interactive class. Okay, so which means that we will we have already have a lot of questions and we'll try to solve as much as we can. So, when will we have this doubt clearing and interactive session? So, it's a weekly session. Okay. So, every Tuesday from 6 p.m. to 7 p.m. till the course runs, we will have this particular interactive session. And so, how do we interact in this particular class? So, in this particular class, we'll be solving questions basically. And the questions are based on the module that you have learned in the first week itself. And how do we solve the questions? So I'll ask questions, you all will answer. You all can post your own queries over there, and other than that, you can raise your hand. Once I ask you to unmute, you can ask your query. Okay, so today's class is also about problem solving, and then at the end we will also have a brief interactive session where you can unmute yourself and talk. So, how else can we clarify all our doubts? Okay, so this is one method where we are having this interactive, you can say one on one discussions. But apart from that, you all are aware about the discussion forum. So, you can always put in any kind of questions that you have in your discussion forum, and that will be answered with the all the queries will be answered. And apart from that, you can keep your questions and then join the next live session. There also, there again I'll be there, so we can again cover our clarify our doubts over there also. Now coming to like why are we having this particular doubt clearing and interactive session? The first thing is because we all know that we have this graded assignments every week. Okay, so we need to answer the questions. So this particular interactive session will help you to answer in a better manner, or maybe it will be easy for you all if you all attend this particular interactive session. I won't really discuss the questions from the assignments, but yes, the questions will be of similar types. Okay, and apart from that, you all are already going through the module, the lecture course. You all are already going through the. Just a second, I need to admit. Yes. So as I was saying that how will this particular course or particular interactive session help you all? So first of all, you all are going through the modules. I hope things are clear. But apart from that, there are some other questions, the assignments that you get. Maybe we need to elaborate on those particular questions a little bit. So we will mostly focus on that part also. So, how is the entire class structured? So, let's look at what we have already studied in our module in week one. So, the first lecture was regarding the introduction to the course, and we saw that where we were taught about, you know, the temporary structures, the permanent structures, and how, what kind of, you know, other construction can be done. So all these things. Then in lecture 2 we focused on module focused on the clay products. Lecture 3 also it covered, you know, clay products. And then lecture 4 was all about stone, how to, you know, mine stone, and what are the different processes starting from quarrying to seasoning. And then what these things were mostly covered. And then lecture 5 was again about stone. And so that was the overall course structure that you all have already, I hope all of you have already watched. Okay, so what's all about today's class? So today's class, as I said, that it will be about solving few questions. So basically I'll be focusing on lecture 2 and 3, which is clay products, and lecture 4 and 5, that is stone. And so we will have some theoretical questions, and we will also have some numerical questions. These are not I mean, it's basically all aligned to the assignment, graded assignment that you all get, okay, every week. And apart from that, we can you know, divide the class into such that maybe the first 40-45 minutes we can answer these questions as much time as it takes. And after that, the later, you know, this 15 or 20 minutes that we have, we can have a range of, you know, all the queries, the other questions that you have in your mind. So I hope this particular structure is clear with you all. Okay. So here comes the first question. So what does it say? It says that identify the bat and closure of a brick. So I would like you all to answer, and then I'll go for explanation. But before that, like, you all keep on answering, but before that, let me just give you a very brief, you know, maybe a recap, I can say, about what we have already learned. So it's all we know that brick is basically, it's a block which is used to build maybe walls, you know, pavements, or any other masonry construction. So bricks are primarily, how do we you know, manufacture brick? We use clay to manufacture brick, and that is the conventional kind of method. That's the conventional product basically, which is used for making brick. But apart from that, we also learned about fly ash brick. We also learned about compressed stabilized earth block, CACBs, right? So CACB is basically, we understand that it's a mix of sand, soil, cement. Okay, so it's basically mixed together. It's this raw materials. Then a bit of moisturing is done by adding some water, and then that entire thing, that mixture of the sand, soil, and cement, that is put into a compressor. So compressor is basically, you know, it's a machine. So yes, I'll just end. Someone has raised the hand. Yes, you can keep your like, you can put it on the chat box, as I said, and later on, once I'm like, you know, in between, then I'll ask you the questions. Okay, is this fine? I hope this is fine. Okay, so as I was telling, let me come back to what I was talking about, CACB. So this compressed stabilized earth block, they are put in the not the earth block, but rather the raw materials of, you know, the sand, soil, and cement. They are moistened and mixed, and then they are put into the compressor. And then what happens after, you know, the machine, it compresses the entire raw material. Then the stabilized blocks basically come out, and that are cured. And after more or less 21 days, it's the curing time. So after 21 days, they are ready for construction. So that's the thing about compressed stabilized earth block. And this CACBs are, you know, as we understand, that these are locally available, because clay, sand, I mean this sand, soil, and this cement, all these things are easily available. So these are quite, you know, affordable as well, and of course energy efficient. And apart from that, we also studied about fly ash brick. So in fly ash brick, we studied that fly ash, the product, the residual product that we have. So that is basically mixed with water, sand, and cement. So once again, the composition of fly ash stays to around 60 to 80%, and then again the entire as the bricks are produced, so using the fly ash, the bricks are once again produced. So this is the basic these are some of the types of bricks that we have learned from our module. And apart from that, okay, so there are several types of bricks also, classes of bricks rather. We will discuss about them when we will solve one particular problem. But before that, can I get the answer about this particular question? Where what do you all think? Image A is the bat or closure, and image B is which one? Bat or closure? You all can type. I'll check the check boxes. Yes, anyone with any answer? Okay, I see Harsha saying image 1 is bat. So we can consider image. Okay, Pankaj also says image A to be bat. Yes, the answers that I get from Harsha, Pankaj, Shaili, Krishna, Sumit, right, exactly. So, image A is bat and image B is closure. So, what is this bat and closure? So, we all can understand from the shape itself. So, if you look into the whole brick, okay, so this is the whole brick, how it looks like, and you all know this one is the frog, the dent that is there on top of the brick, that's known as frog. Now if we cut into this half, that is if we are cutting the particular brick in this manner, so it leaves us with a bat. And if we are cutting the brick along the length, okay, or in this manner, if you can see, so it's known as the closure. Now when we cut the brick along its width, it's the bat. And there can be different shapes of bat, okay. So first, if you see, for example, if we just cut it just along the midpoint of the length, so then we get this half bat, okay. And then we can have three-quarter bat also. So if we divide this entire length into three parts, and if we then cut it if we cut one third of it, so we are left with three-quarter of bat. And then we have beveled bat. So what do we see in beveled bat? So in beveled bat, we see that there's this particular angle, okay. So this particular angle is formed after we cut the brick along its width. But there's an interesting fact about this beveled bat. So beveled bat is cut in such a manner that this particular point, if you see, so this is basically the one third portion, and this portion, the point till which the other end of the brick till which it is cut, is the half portion. Okay, so this is the thing when we this thing we have to remember when we are classifying a particular bat into a beveled bat. And the next one, as we said, so from image the second image or the image B was that of a closure. And again, once again, closures are cut along the length, and closures can be of again different types. So here we see the skin closure, bevel closure, mitred closure. So what this particular closures are all about, or how the cut is done. So if we look into the king closure, so this particular brick is cut in such a manner that the width of one particular end becomes half to that of a full brick. Okay, so this particular width becomes just half. So this is the half portion, right? I hope you can understand. While the width at the other end is equal to the full width. So what does it mean? It means that this particular is the other end, and this is the full width of the brick. So this is the width of the brick, right? So this is full, where the other side is half. Now how do we get this particular kind of closure? We get this triangular portion. This is you can understand that this particular part is the triangular portion. We get it if we cut the brick between the center of one end. So this is the center of one end and the center of the other side, or the lay side, that is known as the lay side. What is the center of the lay side? So this is the center of the lay side. So this, the length of this particular part is once again half the length. Okay, so that is how we get the enclosure. Now coming to the beveled closure. So bevel closure is, again, you can understand that it's cut along the length of the brick, but how? It's again different. So once again, this particular part, one side is cut along the from the half of one side, and the other portion touches the end. So it's like a chamfering in such a way that the half width is maintained at one end. Okay, this is the half width which is maintained at the one end, and the full width is maintained at the other end. So this is known as bevel closure. And the other one is metered closure. So metered closure also, by now I hope you all have understood, got a thing that okay, the bricks are getting cut, but the way we are cutting, that is giving the name to this, different types of the shapes are basically named accordingly. So if you look into the metered cut, so in metered cut what happens, so this one particular end is splayed, so or it's also known as metered, MITRT, okay, or splayed for full width. So in the angle of this play is generally from 60 to 40, like 45 degree to something around 60 degree. So what happens, one longer face of the closure, this particular one face of the closure is equal to the full length of this particular side. So this one particular longer face is equal to the full length of the brick, while the other face, if you look into these particular face, you will see that it's smaller in length. Okay, so this is how we classify, or in fact we so we could rather classify the different types of bag and different types of closure. Is this clear to everybody?
Yes, ma'am.
Okay, so coming to our second question. So second question, let me see how many of you can guess it. So you have to identify the brick bonding. Can you all identify anything? It's a part of the constructions, but yes, of course, this the way bricks are actually arranged. So that gives the importance to this particular understanding of bonding. So let me just see if any one of you can answer this particular question. Should I give a hint? So the answer will be, image A will be either Flemish bond or English bond, and yeah, the other option, from image B, it will be again the other one. So, any guesses from your?
Image B is Flemish bond and image A is English bond.
I think
I think.
someone is answering, but your voice is not, audible. So you can, yes, Krishna. Krishna says image A is English bond. Okay, let me see whether it's correct or not. Absolutely right, Krishna. So image A is English bond and image B is Flemish bond. I'll just talk very briefly about this English bond and Flemish bond, because we are mostly, this particular course is mostly about building materials. So I'll talk about a bit about the construction part also, but in a very nutshell. Okay, let's just see. So on your left hand side you can see the English bond details, and in the right hand side you can see the Flemish bond details. But let me just go back to the previous image once again. So in the previous image, from like, how did I just simply say okay, the image A is English bond and image B is Flemish bond? It's because just by looking at the headers and stretchers. Okay, just a second. Yes, yes, Harsha. English bond is at the left side. Correct. So headers and stretchers. So when we look into a brick, okay. So we see, when we see this particular side, if you just, so this is the suppose this, so this is the height. So this is 75, and this is the width, which is 125 of the standard bricks that we use in India, and this particular longer side is how much, 250 right? So if you look face, or if you see this particular section, so we call it as the header side. Okay, and what is the stretcher side? So if you look, if you can see this particular dimension, or rather you can say this particular side. Okay, so that is the stretcher side, or let me just one second draw it over here. Okay, so you place the brick. So this is the frog. We all know that it's the indentation that is done on top of the brick so that the mortar can be held properly. Okay, so if you see this particular side, so this is the stretcher side. Okay, so this English bond and Flemish bond is all about, what, it's about how you're placing the bricks. That is how you make a bond. So apart from this, there can be different other types of bond. There can be Dutch bond, there can be a rat trap bond. Okay, there are numerous number of ways how you place a brick and make a brick masonry. So here we are just talking about the simpler ones, the ones which we mostly come across. Apart from this, we also see stretcher course, header course. All those are also there, but these two are also quite common. Now in English bond, what happens if you look into this particular courses? Course means the way, in a way, arranged way the bricks are placed. So that is what course is all about. So if you see, can you identify this particular thing? Again, this I think it's a red. Actually, I can't change the color. Okay, anyways, I hope things are a bit, you can see this particular portion. So can you say whether this is the stretcher bond or the header bond, or this is the stretcher side or the header side, or the stretcher pose rather? It's the line of,
Header course.
this is the header one. Very good. And just above it, can you tell me this one is header or stretcher?
A stretcher. A stretcher.
This one, yeah, this one is the stretcher. Absolutely correct. Now, once again, just look into just the course above the stretcher. This one. Can you
Again
identify?
header.
Again, header. So, from here only, I hope it's clear to all of you that if the bricks are placed in an alternative manner of header and stretcher courses, then what happens, then this English bond, or English bonding, whatever, however you want to name it, so this particular bond we can get it. Okay, now let's come to the Flemish bond. So Flemish bond, just see this one is the which side, header side or the stretcher side? Yes, Shirley, correct. So this is the stretcher side. Very good. And just the next one, yeah, it's the header one. Okay, so this part is the header one. Very good. So here we can see that, okay, I'll just move to my, just a second, I need to admit. Just a second. Just give me, huh. So in this particular slide also, that is what it is written, and it will just change. Yes. So you can see it over here. So in English bond, what happens? Alternative courses of headers and stretchers. Whereas in Flemish bond, what do we see? In each and every course, there is one header, there is one stretcher. But interestingly, it will lead to our next question once again. If you look into this particular thing, you'll find that, if you remember in your module, there was this one particular part where it said that do not form vertical lines when you are placing the bricks. Here also you'll interestingly see both the images. Okay, you'll find that not only the vertical joint is, it's staggered, like there's no, obviously there's no formation of vertical line with the help of the joints, but apart from that, there's also another thing. You see this too, and then there's again this particular gap. Again, if you check any other this particular course, so this one, and then there's a break. So this particular thing, the way of staggering, or rather the way of arranging this particular bricks in this manner, helps in not only, of course, one is we will talk about that, vertical, what will happen if the vertical, this particular line is created with the help of the joints. So not only that is eliminated over here, but apart from that, you can also eliminate, the formation of, a plane of cracks. So if it would have been like this, like, this in all, after the arrangement of all the cores, even then the particular masonry structure can also, develop crack along this particular, this particular pattern that it gets, and then it can fall off. So, in order to avoid that, also this particular Flemish and English bond, these two are great examples where you'll see that even in each of the individual courses, also you'll see this particular, this continuation is basically broken. Okay, so that is all about. So, how do we achieve it? If you ask me that also, so it's all about how we place the this closure. So, if you see here, the closure is placed over here. Okay, so in every alternate, this particular courses, the closure is placed over. So it's all about how you place the closures. Even here, you see here, this particular, here three-quarter closures are placed. So that basically helps in, reducing the formation of this continuation of the joints. Okay. Okay, now coming to the continuation of the previous discussion, like the discussion that we were just doing. So here, it says that what is the reason for avoiding a continuous vertical joint in masonry? Can I get the answer? It's quite a easy one.
B, option B.
Yes, very good. Yes, Pankaj Shaili.
B, ma'am, B.
Yes, yes, absolutely correct. Yes. So it's the lateral forces on the wall. Sorry, it's not, it's written AOF and written BOF. Right, you all are correct, but yes, the lateral forces on the wall have a tendency to break it along the vertical joint. So what basically happens, what do we mean by lateral, forces? So lateral forces is basically the forces which pushes the wall from the, or the horizontal forces that pushes, and as a matter of fact, what will happen, this entire thing might get, displaced. Although I am drawing it in an exaggerated manner, obviously not so much of displacement happens, but the actually the force works like that, and the displacement actually happens, and as a matter of fact, what will happen, this entire structure can topple down. Okay, so that is why, this particular vertical joints are, you know uh, avoided. And if there are vertical joints, then you can understand the entire thing will just, topple off. Also, there's this particular thing about brick delamination. So in this brick delamination, this is a particular situation where, the brick wall, you can see over here how the brick structure is basically falling down. Okay, and this can, it can be a very dangerous thing. Generally it happens for old buildings, where the mortar becomes weak. Okay, but it can also happen for, newer structures where the construction is not done properly. So that is why we were discussing about the bondings. Okay, brick bonds. Okay. Now coming to my fourth question, where you need to identify the type of stone masonry that is used in the building. But before that, let me just give you a brief recap about, if you just can recollect about the stone masonry that was taught in the course. So the stone masonry can be, classified into, two categories. One is the rubble masonry, and the other is the ashlar masonry. So what do I mean by rubble masonry? So in rubble masonry, we use, undressed or roughly dressed, rather, this kind of stones, and generally it doesn't have, the construction doesn't have, uniform thickness, uh, and the strength of that particular rubble masonry, it depends upon the quality of mortar that is being used, or, the how the stones are, how the shape of the stones are, so it depends upon that also. Or, how you are filling the gaps, because that is important, because ultimately, the stone should, it should be hold properly, otherwise what will happen, once again it will break. And furthermore, we can again, we have seen that how the rubble masonry can be classified into post rubble masonry, unpost rubble masonry, dry rubble masonry, or polygonal masonry, flint masonry. So all these things we have already seen on in our, course module. So just recapitulating about the things that you all have studied in your, like in the lectures, just try to answer this particular, what type of masonry do you all feel? Like, is it like
I
somewhat?
think dry rubble.
Okay, I started getting answers. Yes, Harsha. Okay, Harsha says post rubble masonry. Um, Yes, absolutely fine. Like you all are correct with like post rubble masonry. But if we look into very particularly, this is also post square rubble masonry. So the answers that you all have given, rubble masonry, and obviously Harsha with post rubble masonry, this is absolutely correct. But in a much more specified manner, this is also squared one. Why? Because yes, Santosh, it's a rubble masonry. Why it's this square post rubble masonry? Of course, post, because you can see that a particular, you can see some distinct courses or lines rather. Okay, so that is why it's post. Rubble masonry, why? Because you can see the shapes of, there are different shapes, not only different shapes, but the appearance of the particular this wall or this particular building. It looks like, it's not properly dressed stones, so it's roughly dressed. And apart from that, the facing stones, this particular are the facing stones, the ones which we can see, very, slight hammering has been done just to give a particular, squarish shape. So that is why this particular name. Okay, and we can see that why also in course we can see that chips are not used as bedding. So there are the small stones are not used as bedding. Okay, okay, now this one, I didn't, this one is quite a, this one is again an easy one. So again you have to identify the stone masonry that is used in this particular building. Yes, anybody, any guesses?
Flint masonry, I think.
Yes, anyone else feels that it will be flint masonry? I can't see who is answering actually. So sorry, I can't take your name, but yes, whoever you have answered, it's correct. Okay, just a second. Yes, it's flint rubble masonry. So flints are basically, if you check what are flints, flints are, this irregularly shaped these nodules of silica. They are basically crystalline, small this sedimentary rocks rather. So they are very hard, but they are somewhat brittle. Okay, and how are this particular construction done? So the splints are placed, the splints are placed, and then they are basically, filled with quite a large amount of water. So that gives this particular type of, finish. So this is the filled rubble masonry, and this one, this is the
Dry
image
rubble.
of a boundary wall. Yes.
Dry rubble, I think.
Yes, this is dry rubble masonry. Why it's dry rubble? Of course, we can understand that.
Because mortar has not been used.
No mortar is used, absolutely. And the smaller, the spaces, the voids are basically filled with the smaller pieces of this particular uh, this stones. Okay, so this is dry rubble masonry, and this type of masonry you will very much see, during the construction of dams, or also if you check, if you go to sea beach and all, you'll see that this particular dry rubble masonry is done, so that the maybe the beachside villages or towns, whatever it is, they can be protected from the tide waters. Okay, yes, absolutely correct. So coming to this another type of stone masonry. Now the hint is, this is not rubble masonry. This falls under another kind of masonry, which I just mentioned. No, I just said, but I didn't talk about it in details. Yes, anybody? Any guesses? Okay, so this is ashlar masonry. Okay, so what is this ashlar masonry? So in ashlar masonry, we use finely dressed stones. Okay, so this is the this use of, finely dressed stones is the key component or the key word of, this ashlar masonry. And just a second. Okay. And generally, what happens? The stones are somewhat proportionately cut. Okay, and they are placed in such a manner that, it gives a proper, at least it gives a very finished look. So even there are various types of ashlar masonry. Just as we were talking about different types of rubble masonry, so it can be ashlar fine masonry, it can be ashlar chamfered masonry, where basically what happens is, you see this top layer. So these are basically chamfered. Chamfering is basically nothing but, if you see this kind of block and if you like chamfered like this. Now, of course, this particular image that I have drawn is very much exaggerated, but yes, the chamferings are done where just at the corners, it's just just chamfered. So that is what chamfered masonry is. There can be also ashlar rough tool masonry. So what happens? The tool is being used, but the finish is given in such a way, na, you'll just look and see, you'll just find there's a rough look. So that is what ashlar rough tool masonry is all about. Okay. Okay, now let's come to our next question. So, what does it say? It says that you have to select finishing material for the interior of your kitchen. Okay, so now what are the materials? You select for the countertop, you select for the flooring, and you select for the dado. So already you can see there are several materials given. For example, ceramic tiles, then
I think option
basalt,
B.
nails, Pota stone, quartzite, slate, marble, and of course sandstone. Okay, so these are the basket of materials that you already have, and from here you have to select. Now we have also seen in our this particular course where we have seen how we have to select materials not only as per the looks, the aesthetics, but also as per its property also. We have to understand what kind of use of places, there are different spaces. So all the spaces are not used similarly. There can be different usages of spaces. So accordingly, we need to select materials. So here we see that countertops. Countertops are places where you'll put you'll chop your things, this vegetables and all, where you'll cook, and you might spill oil, you might spill water. So you have to choose such a material that has got lesser absorption quality, that is durable, that is hard. So these things you need to understand. Once again, flooring is again, in a kitchen you can understand you are using heavy utensils, you are using sharp material, sharp these things. So again, flooring needs to be such that it can withstand all these things. And dado or the cutting, so the side things, and also this dado plays a very important role in kitchen, because you can understand this. If you are, suppose you are uh, moving your cylinder, gas cylinder. So the dado, they are very susceptible that it gets broken very easily. If you check into your house, you will find that in the kitchen cuttings, if they are made of very fragile tiles or something like that, it generally gets somewhat broken. So you have to you select such a material that even those dado or these cuttings, they are they are not easily broken. So keeping all these things in mind, we select that the countertop can be made of granite, the flooring can be made of pota stone, and the dado can be made of quartzite. Okay, so let's just get a check of the the images how it might look. So if you see this particular granite is it's now visible, I hope. So this particular okay, so I see quite a lot of you all have answered. Shelly, Harsha, Rashmi, Santosh, yes, all your answers were correct. It's option B. So you can see this granite countertop, then you can see this this type of Kota stone flooring that has been done, and of course this use of quartzite layer. Okay, now I have one small question for you all. Can you all identify the type of the rock or the type of stone this granite is? This we have seen when we were when ma'am was teaching us about the different classification of rocks. So can you all just recall that granite, this is what kind of stone it is? Okay, let me just give another hint. Okay, before I give the hint, I get the answer. Yes, Rashmi, it's igneous. So it's a type of granite is an igneous rock. Okay, and Kota stone is sedimentary rock. Can someone tell what quartzite is? Kota stone is basically it's a type of limestone which is widely found locally found in Rajasthan. Okay, okay. Rashmi again says it's a metamorphic rock. Yes, absolutely correct, Rashmi. Okay, now we have one very small numerical. I would love if you all do with me, if you all have a pen and pencil, just do it with me. Okay, it's not very difficult to do. It's an easy one. I'll explain it step by step. But yes, if you all can answer, like give the answer, obviously it will be a bonus. So what does it say? What does the question say? So it says that you have to construct a 10-inch brick wall, okay, of 1 meter length and height is 1.2 meters. Now we have to find the total number of bricks that are required to build a wall of English bond. So when I say English bond, what comes in your mind? Alternative layers or courses of, yes, absolutely correct, Rashmi. Stretcher and header. Okay. What does this particular question again states? It states that assume that the size of each brick is 125 by 250 by 75 mm. Okay, so that's the mostly the standard size of brick that we find in India. Okay, so how are we going to do it? So, since I said that alternative courses of stretcher and header, so let me maybe, of course, let me assume that I am taking, the first layer to be the stretcher course. Okay, so how do I put the stretcher course? Okay, another thing we need to remember that the length of that particular wall will be how much? 1 meter. And when I say 10 inch, 10 inch is basically nothing but 250 mm. Okay, I hope this part is clear to all of you. So we have to build this 1 meter long wall, and also we will talk about the height. We'll come to the height part later. Okay. So when I say it will be 1 meter, 1 meter is basically equal to how much? 1000 mm. So we also know that. So when I say we will put it, the first layer will be the stretcher layer. So how the bricks will be put? Like this. So this is the 250 side and this is the 125 side. Sumit says I think 105 bricks. Okay, Sumit, you just follow. If I'm wrong, the answer is not 105. You can try it once again. But yes, if I'm wrong anywhere, you can always rectify my this answer. But yes, let's see if others also agree to what I say. So this is the particular size. So we have to again place, another one. So how many are we going to put? So we are going to put how many? 1000 divided by 250. So that will give us the answer. So that is 4 bricks. Okay. So here we are going to put 4 bricks. So similarly, since it's a 10-inch thick brick wall, so we need to make it another, we need to put another 125 mm, which will in total give us 250 mm, that is 10-inch thick brick wall. So another 4 we will put. Pardon my drawing skill and the scale that I am using, I mean the drawing scale basically. So let me just consider this part to be no. So in this manner we are going to put the bricks. So this is the first layer. Okay, now in first layer how many bricks did we use? 1 2 3 4 5 6 7 8. So 8 bricks. Okay, yes, you can question me that what about the mortar of 10 or 12 that we give. For the simplicity of this question, let us consider we are not using mortar as of now. Okay, we can, if we put mortar, then the length will again get increased a bit. Okay, so here 10, here 10, here 10, and maybe 60 70 it will get increased. So let's just keep that thing aside. So this is with the first layer. Now with the second layer, how are you going to put it? So you're going to put the second layer just on top of this first layer. How? So this will be the second layer's first brick. Okay, so that's a entire brick. But then we have to break the particular joint, right? So for that reason, what we will do, we will use a closure. So we will use a queen closure. What is the dimension of that queen closure? This particular side is 250, because just imagine, okay, we are putting this particular brick on top of these two bricks. Okay, this brick and this, so it's something like putting it on top like this. Okay, this particular thing only I am drawing it separately. So we put a queen closure. So this one, the length of this is 62.5 mm. So in this way, let us just find out, since it's 1000 mm or 1 meter, so how many bricks we will, in general, we will require. So basically 1000, how are you going to find out? 1000 divided by, and the length, this particular width of this particular side is 125. So if we do, how much do we get? 8. Okay. So we have to in total put 8 bricks in such a manner that this entire length of 1 meter gets covered. So we will put maybe in some way or the other. So 1, 2, 3, 4, 5, 6, 7, and then sorry for the scale, and then there will be again a queen closure, which is of 62.5 mm. So you can understand we are using 7 full bricks and 2 closures, which is again coming to equivalent to 8 bricks in total. So for each layer we require 8 bricks in whichever way you put, in either the stretcher course or the header course. Okay, so that thing is clear. So first layer is clear, so this was our second layer, so that is also clear. Okay, so 8 bricks, 8 bricks. Now coming to the height. So 1.2 meters. So how do we convert, or how do we find out how many layers do we need? So 1.2 meter is basically 1200 mm, right? 1200 divided by what is the height of each of the brick? It's 75 mm, right? So if it's 75 mm, so if we calculate this one, so we get 16 layers. So in total we'll have 16 layers. So for each of the layer we have 8 bricks, and in total we have 16 layers. So 16 into 8, that is equal to 128 bricks. So 128 will be the answer. Okay, this is what. Is this clear to everybody? Yes, Sumit. Sumit has got the answer correct for the second time. Yes, I understand. That first one was with mortar, because you somewhat covers up this 80 or 90 mm by putting the mortar. So yes, it's quite natural. Okay, Harsha. So I hope it's clear to everybody. So I can move to my next question. Okay, so this question you have seen in your assignment this time also. It's a similar question, but it's not the same. Okay, so here once again, what happened? We are selecting 3 bricks from a random brick lot. So how does this thing happens? This in reality, how we check the weight of this bricks. Sorry, I mean how we check the class of each of the bricks. So what happens? There's this lot of bricks, maybe 1,000 bricks. They come, and randomly 6 or 7 samples are taken. So 6 or 7 is the standard size. So 6 or 7 samples are taken, and then they are first they are weighed. So that is the initial weight, and then they are submerged in the water, and then they are taken out, they are clean, and then again they are weighed. So that gives you the final weight. So that is the entire procedure about how we measure the weight. So here also we have brick P, Q, R, and we have this initial weight and final weight. So we will quickly see that how much are we getting for each of them. Now, what is the formula, or what is the, how do we find out? So if we consider, okay, just a second. Yeah, if we consider this initial weight to be W1 and the final weight to be W2, so how do we find out? We find out by W2 minus W1 divided by W1 into 100%. So that gives you the percentage of water absorption that has happened, or the changes that has happened, and that according to that we will classify the bricks. So if you look at brick P, so brick P, what do we have? We have 3.14 minus 2.65 divided by 2.65 into 100. So that is giving you a value of how much? Okay, similarly we will do for the other Q also. Q also we have 2.90 minus 2.57 divided by 2.57 into 100. Okay, and for R also, how do we do it? R also we do it by 2.85 minus 2.31 divided by 2.31 into 100. In this way you can find out n number of like the weight, or the changes in the weights. And so let's see what's the answer. Yes. Okay, so okay, Sumit says Q is 1. Yeah, that's first class. Absolutely correct, Sumit. And P is second class. Yes, correct. Again, once again, correct with Sumit. And R is third class. So we get the answers to be, this P, this particular value is 18.5. For R, we get 12.8%. And sorry, for Q, we get 12.8%. And for R, we get 23.4%. So if you just remember this particular chart, yes, this is showing now. So if you remember, so first class brick, the water absorption is 10 to 15%. The second class is 16 to 20%. Third class is 20 to 25%. And fourth class is greater than 25%. Yes, Harsha, yours is also correct. Okay. Yes, right. R is R. Okay. So anyone having any doubts from here? I hope not. This one is clear, and I hope that now you all will be able to easily do the assignment. So that more or less brings an end to our this particular interactive session where I basically just talk. And before I uh, end this particular presentation and I take up your other queries that you all have, it's just identify some buildings and the materials that are used here. You all can unmute yourself and you all can say it. Okay, so these are very common buildings. Maybe you'll know some, you'll not know some, but at least you will be able to identify the materials. I can say this for sure. Okay, can you all identify the material? It will just come in the screen. Just wait. Oh, yeah. Now I hope it's visible. Thank you, Krishna. Yes, anybody like what material is used? Yes, Shelly, it's brick. Okay, just if okay, Rashmi. Before I just asked, Rashmi says it's IIA. Yes, it's not necessary for your course. Just it's just for just a general thing. Yes, Krishna, it's red brick. So it's IIA Ahmedabad, the brick work, and this is a very famous architectural building as well. Just a second, I'll just admit a few who have come. Yes. So okay, next one. Can you all guess? This is again, it's quite evident, I hope. Harsha says red brick. I hope the answer is again for the second image that we have. Yes, it's red brick, and this is the coffee house in Thiruvananthapuram, which was designed by Laurie Baker, very well-known architect. And yes, Krishna, you're correct. It's brick. Okay, this one we all know. Yeah, this is Taj Mahal, but our focus is on the material. Yes, it's marble, right? Yes, absolutely. Those who all are answering, it's absolutely yes, Priyanshu. Very true. It's white marble. So it's Taj Mahal. Okay, this one. Your work is your primarily to identify the material. Yes, it's sandstone, shelly, And anything else can you see? Okay, Rashmi also says sandstone. Yes, absolutely correct. Apart from that, anything else? This portion maybe some guess. Harsha says red brick. Oh, that's interesting. Okay, so it's not red brick, Harsha. It's red sandstone. And if you look into the tomb, and there are some other this particular claddings. If you look, so it's marble. Yes, Pankaj, absolutely correct. It's sandstone and marble. Okay. Okay, this building might not. It will just come. Okay, just wait. Hold on. Yes, this building might not be very much well known to you all, but you all can always answer what material that has been used. Let me give you a small hint. It's located in Delhi, and it's a beautiful work by very famous Raj Reval architect Raj Reval. Yes, it's actually it's the National Institute of Immunology and New Delhi, and yes, beige and pink sandstone has been used. Okay, so yes, Harsha, Shelly, you all are correct. Correct. So that brings an end to my part. And if you all have any queries, if you all have any doubts, any questions, you all can ask me. Can we do volume of wall or volume of brick? Do you mean you need to find? I didn't get your question, Marvin. Can you just a bit, clarify? Can we do? You want me to answer one, put one numerical regarding how to find out maybe volume. Okay, number of brick is equal to volume of, see what happens. Sometimes you might find that you can easily do like number of bricks. You can find by divide like volume of wall divided by volume of brick. Maybe you'll get the answer, but you'll have to remember that not all bonds, that thing that we were talking of, not all bonds are same, right? So there are several times when this particular thing won't work. So because there will be usage of bats, there will be usage of closure. Okay, so accordingly you need to understand each of the layers how they are formed, rather than just dividing and just finding the numbers. It might not even if you there's this type of bond which is known as a rat trap bond. Okay, so in rat trap bond what happens, a particular cavity is formed in between. So in those kind of bonds now you can't really do it, because if just imagine, I'll just draw it. So the bonds are something like the how it looks something like this. I don't know if I'm drawing it correctly. No, I'm not drawing it correctly. I'll just redo it. So it's like this. Okay, so this is how it looks from a plan in rat trap bond. Okay, now just imagine this part is actually hollow. So how are we going to calculate that particular volume, we will not consider this particular part, right, in our calculation. So there you need to exactly find out. Maybe in some cases you will find that it's an easy method, but the actual method is by understanding each and every how each and every course is laid, how each and every bond is formed. Okay, so I give you all an easy question, so that's fine. Okay, thank you, Marvin. Thank you, Rashmi, Shelly, everyone. If you all have any question, once again, you all can post it. You all can raise your hand and ask me. And if not, then we can call it a day. And thank you for attending this interactive session. I hope you all have enjoyed it, and we'll meet again next week. So with the next, a set of lectures or the next set of topics that will be covered. Okay. Thank you, Prangshu. Thank you, Krishna. Thank you, Pankaj. Haha, you'll get this PPT, Marvin, because I'll share this with the NPTEL team, and it's already shared. And so you all will get access to this particular PPT. So no worries about that. Okay, thank you everyone.